let's look at a proof for universal introduction. Now this is a backwards type of reasoning step. You want to introduce a universal quantifier that exists somewhere down the line in your proof, and you want to be able to arrive at that. And so here we have a simple sequent. Again, it's the same one that you would have seen in the lightboard session, and we want to introduce this universal at the bottom. So in a backward step, universal introduction doesn't require any variable for us. It actually introduces a variable. So it says if we assume some actual I and we're able to derive Q of I, then we can say that universally it holds that Q of I holds as well. So now that we have this actual I, this is a variable that we can use for other steps inside of our proof. And so in this actual I, we can tie it together with a universal elimination step. So in the forward path, we'll select this variable and then eliminate and get P of I implies Q of I. And the final step here is to look at our other premise and say for all x P of x, well, we'll use this variable I again. And in a forward step, we'll use universal elimination and get P of I. So now we can take these two and applying the very simple implication elimination, we arrive at Q of I. So again, the universal introduction has happened in this final step here. We wanted to introduce this universal quantifier at the bottom of our proof. And in doing so, it creates this assumption box for us and assumes an actual I at the top of it. And so this is how we go about with universal introduction, and you'll start to see in some of these examples how we're sort of mixing universal elimination and introduction to sort of strip away the quantifiers and then to put them back on in different ways. That's it for now, and we'll see you next time.